So far, we reviewed the real number line and used it to construct the xy plane. We also learned how to graphically represent points on an xy plane. We can plot infinitely many points on the xy plane. What if we want to select a handful of points from the xy plane that satisfy a certain condition? Let's say we're interested in a set of points that lie on a straight line. We algebraically define a set of points that lie on a line using a linear equation. Before we get into the details of how we can find the algebraic equation of a line, let's look at what a slope of a line is. Now, suppose we have a non-vertical line. A slope is the measure of how steep the line is. Higher the slope, steeper the line. How do we calculate the slope? To calculate the slope of any line, we need 2 points that lie on that line. Let P1 and P2 be 2 points that lie on a line that we want to calculate the slope for. And let P1 have the x-coordinate x1, y-coordinate y1, P2 be x2, y2. The first step is we calculate the difference between the y-coordinates of the 2 points. We then calculate the difference in the x-coordinate of the 2 points. And slope of a line is a ratio of the difference in y-coordinates to the difference in x-coordinates between the 2 points. It's usually denoted by the letter m. So the equation of m is m equals y2 minus y1 divided by x2 minus x1. The magnitude of the slope tells us how steep the line is. If the slope is very high, it means that the line is steep. If the slope is 0, then that means that the line is a flat horizontal line that's parallel to the x-axis. The sign of the slope also gives us a sense of direction. When the slope is negative, it means that the line is falling to the right. That is, as x increases, y decreases. When the slope is positive, it means that the line is rising upward. That is, as x increases, y also increases. Now that we learned how to calculate the slope of a line, we are ready to learn how to construct a linear equation. There are 2 ways to construct a linear equation. Let's look at the first one, which is called the point-slope form. Suppose we know 2 things about a line. Its slope, let's call it m, and then a point x0, y0 that lies on the line. Let xy be any other arbitrary point on the line. Using the definition of the slope that we learned earlier, we know that m equals y minus y0 divided by x minus x0. Multiplying both the sides of the equation by x minus x0, we get y minus y0 equals m times x minus x0. This is the equation of a line in its point-slope form. Let's do a quick example. Let's say we want to find the equation of a line that passes through 2 points, 1, 2, and 5, 8. So 1, 2, and 5, 8 are ordered pairs. Let's first compute the slope of the line. To do that, we first compute the difference in the y-coordinates. So in this case, it's 8 minus 2, which is equal to 6. We then compute the difference in the x-coordinate, which is 5 minus 1, which is 4. The slope is the ratio between the difference in x-coordinate to the difference in y-coordinate. So the slope is 6 divided by 4, which is the same as 3 over 2. Now, to get the equation of a line, we pick one of the given points. So in this case, let's just pick 1, 2. So the equation is y minus 2 equals 3 over 2 times x minus 1. Simplifying this equation, we get y equals 3 by 2 x plus 1 by 2. Let's now look at another way to get the equation of a line. And this is called the slope-intercept form. And we use it if we know 2 things. If we happen to know the slope of the line again, and then second is if we know the y-intercept. Now, y-intercept is the point where a line intersects with the y-axis. So let's say we have a line that has a slope m and intersects with the y-axis at 0, b. Substituting these values into the line equation, we get y minus b equals mx. Now, adding b on both sides, we get y equals mx plus b. And this form of the line equation is called the slope-intercept form. Now, what if the line is vertical? When a line is vertical, it means that the x-coordinate of every single point that lies on that line is the same. And let's say the line crosses the x-axis at the point b0, then the equation of this line is x equal b. Now, the slope of a vertical line is undefined here, because since the x values of every single point on the line is the same, by the definition of a slope, when I find the difference in the x-coordinate between 2 points, it's going to become 0, and division by 0 is undefined. Therefore, the slope of a vertical line is undefined. Let's now look at how slopes of 2 lines are related to one another. When 2 lines are parallel to one another, their slopes are equal, and parallel lines never intersect with each other. When 2 lines with slopes m1 and m2 are perpendicular to one another, then their slopes are negative reciprocals of each other. Let's see why that is true. Let A be the intersection point of 2 lines with slopes m1 and m2 that are perpendicular to one another, meaning the angle between these 2 lines is 90 degrees. Let's now draw a horizontal line of length 1 from A. And let the other endpoint of this line be named O. Now, the line segment AO has length 1. Let's now draw a vertical line that passes through O and intersects with the lines at point P and Q respectively. Now, from the equation of the slope, we can find the length of the line segments PO and also the line segment OQ. And we can see that PO is M1 and OQ is negative M2. Here, the slope is negative, notice, because the line is falling downward in a way. Let's also examine the 2 triangles AOP and AOQ. They're both similar triangles because the corresponding angles are equal. Therefore, by way of similarity, the ratio of their corresponding sides are also going to be the same. Now, applying this property, we can see that m1 divided by 1 equals minus 1 by m2, which is exactly what we wanted to prove. Let's do a quick review of everything we studied so far in Unit 1. I use concept maps as a study tool because it helps me logically connect different concepts to one another. So today we focused on how we can algebraically represent a set of points on a line using a linear equation. More to come. That's all I have for today. Talk to you soon.